Here we go. Here we go now. Something like that, right? All right, in this video, we have graphs of exponential functions. Graphs of exponential functions, yes. Coming to you live. So remember, exponential function has a variable in the exponent. So there's kind of two parent functions that we have for these things. One is called our growth, right? Not the hairy mole you have on your back. A growth. So as something goes along in time, it continues to increase. That is when a, our base, is going to be greater than 1. So if I have anything to the 0 power, a to the 0, anything to the 0 power is always 1. So no matter what for these exponential functions, they're going to have a y-intercept of 0, 1. After that, if we have a growth, it's going to continue to say it doubles over time. And we have 3, 8. So I'm going to continue to grow very, very rapidly. From the other direction, what it's going to do is it's going to get closer and closer, but it will never be 0. It gets closer to that thing that we call a horizontal asymptote. For both of these, we will have a horizontal asymptote at y equals 0. Unless that moves up or down, it's going to stay at y equals 0. For the other one, if we have a rate between 0 and 1, that is something that is shrinking over time. So this is called a decay, and it is going to shrink. So it's going to get smaller and smaller. So again, anything to the 0 power is going to be 1. So then if it decays, it's going to decay away to nothing. It's going to wriggle and die. And it would be the opposite there. So notice like these are reflections of each other. Cool. They both have y-intercepts of 0, 1. They both have horizontal asymptotes at y equals 0. All right. Other than that, let's get into it. We only got a few. So graph and state the domain and range of each. So if I have 2 to the x, 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. You guys catching what I'm doing? I'm putting in the x values, right? So x value is 0, so 2 to the 0 is 1. That's why I have a y value of 1. 2, if I put in 1, 2 to the first is 2. 2 to the second is 4. 2 to the third is 8, right? It's kind of what we were doing in the example that we did up there. And then as it goes this direction, it's going to decay to nothing. But this is still a growth. So now for the domain, this is going left and right forever, so negative infinity to infinity. And for the range, notice it's getting closer to 0, but it's never going to touch it. The reason why that is if I do like 2 to the negative 99, remember about those exponent rules we talked about in the last video? It would be the same thing as 1 over 2 to the 99, which is just 1 over a really big number. Big number. 1 over a big number, which is not 0. It'll never be 0. It's not possible. So that's why we have our horizontal asymptote at y equals 0. It's going to get really, 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 really close, but it's never actually going to touch it. Range. So it's going to get close to 0, but it's never going to touch it. It's going up forever. So notice on that 0, I put a parentheses to indicate that it is getting closer and closer, but it's never actually touching at 0. All right, that's it. That's all they asked for. So we have here 1/2 to the x. So again, this is a base between 0 and 1. So I have y-intercept of 0, 1 all the time. And then if I take half of that number, it would be at 1/2. Half of that number is 1/4. Half of that is 1/8. So this is going to get closer and closer to 0 in this direction, but never actually touch it. Remember, there's a horizontal asymptote there. The other direction is going to increase forever and ever. So I have a graph looking like this. For the domain, still, it's going left and right forever. For the range, still hasn't moved up or down, so it's getting closer to 0 and going up forever. All right. So this one, my tops keep getting cut off. F of x equals 3, 2 to the x. 3 times 2 to the x. So notice this 3 is not with the x. So what this does is it's going to multiply our y values by 3. So my parent function would have started at 0, 1, and it would have done something like that. So now if I take all my y values and I multiply them by 3, the y value here is 1. 1 times 3 is 3. I'll keep the x value the same, but just change the y value. The y value here is 2. 2 times 3 is 6. The y value here was 4. 2 times 4 is 12, so that's way up there. So what's going to happen is if I follow this function, as I'm going down, is it's going to get closer to 0 still. It's not moving up, so I'm not moving my asymptote up or down. So the domain is still negative infinity to infinity, and the range is still 0 to infinity. Didn't move up or down. The only time our range is going to change is if we move our asymptote up or down. All right, with D, hey, we've been talking about it. So I have a 2 plus 3 to the x. The base is greater than 1, so this is going to be increasing. Now what this 2 does is it takes the entire graph and moves everything, including the asymptote, up 2 units. So this asymptote that used to be at 0 is now at 2. So I'm going to start my graph by saying I have an asymptote at 2. Then the y-intercept of 1 was moved up 2 to 3 now. So I'm going to get closer to my asymptote on that side. And then I know since I'm a growth, because my base is greater than 1, my graph is going to grow in that direction. Yeah. All right. And this one, I have negative 1 plus 3 times 1/2 to the x. So what this negative 1 does, it's not with the x, so it moves it in the y direction, so it's going to move everything down 1. I notice also that I have a base that's 1/2, so I know I'm going to have a decay function. Wow, that's not supposed to go back up. Yeah, you're supposed to go down. Just ignore that altogether. There we go. That's a little bit better of a decay function. The 3 still multiplies the y values by 3, so instead of being at a y-intercept of 1, 1 times 3 is 3, so I have a y-intercept of 3, and then I'll move everything down 1. So here's my decay parent function. Something like that. And then if I multiply the y's by 3, 1 times 3 is 3. Whatever this is times 3 is higher. Right? So this will grow a lot faster and decay a lot slower. Then I'm going to take everything and move it down 1. So down 1 unit would put it at 2. And it will also move my asymptote down by 1 unit. I just realized we didn't do the domain and range on the last one. I'll come back for it. So this is going to get closer to the asymptote in that direction and go away from the asymptote pretty quickly in that direction. So there in pink is our final graph. So for the domain, still going left and right forever, so negative infinity to infinity. And the range, the lowest y value I have, is getting closer to that horizontal asymptote of negative 1, and it's going up forever to infinity. All right, sorry, coming back for the domain and range on this one, I forgot. My B, yo! All right, domain, still going left and right forever, so negative infinity to infinity. And the range, the lowest y value I have, it's getting closer and closer to my horizontal asymptote of 2, so from 2 to infinity, going up forever. All right, other than that, that's all I got. There's nothing on the back. Let me know what questions I can answer for you guys as you go through your quizzes and everything. All right, I'll talk to y'all soon. Bye.